Hi guys, today we will be discussing mass and volume, what they are and how we can experimentally measure them. So first, let's talk about mass. So mass is simply the measure of the amount of matter that is present in an object or in a sample. So when we're measuring an object or a sample's mass, we simply are measuring how much matter or how much stuff is present in that object or in that sample. The SI unit for mass is the kilogram, as you will remember from our units lesson in Unit 0. However, smaller values, which is generally what we will be dealing with in class, are measured in grams. Remember that a kilogram is 1,000 grams. The way that we measure the mass of an object or a sample is by using a scale. A scale looks like this that you see on the screen. There also are older types of scales like balance scales, but we will be using digital scales nowadays. Now, most importantly, for where we are heading in this unit, is to understand that mass is dependent upon the amount of substance that is present. For that reason, mass is not a property that can be used to identify or differentiate substances. Let me give you an example of what I mean by that.
So what do I mean when I say that mass is dependent upon the amount of substance that's present? It's a very simple concept, but very, very important when we come to our chemical reactions unit. All that means is that if I have a substance, for example, this sugar here, and I have perhaps 1 tablespoon of sugar, that is going to have a certain mass. Now, I could take the exact same sugar, and instead of taking 1 tablespoon, in this second pile, I'm going to take 2 tablespoons. Now, in this second pile, there is a larger amount of sugar present. Therefore, this pile will naturally have a greater mass than the pile with less. Now, that does not mean that these 2 samples are made of different substances. It simply means that there are different amounts of that substance present. So as we move forward, it is important to remember that mass is dependent upon amount present. Therefore, it cannot be used to identify the substance because as we can see very clearly here, I can have 2 samples of the exact same substance with very different masses. Again, based solely on the amount of substance.
Now, let's talk about how to measure the mass of substances in the lab. So now I'm going to demonstrate for you how to measure the mass of a solid object, a powder, and liquids.
First, let's look at how to measure the mass of a solid object. First, you want to take your scale, sometimes called a balance, and place it on a flat surface. Then you simply want to turn it on, wait for the reading to come, which should say 0.0. If for some reason the reading does not say 0.0, you want to hit here the tare button, or on some scales, it may say simply 0. Now for a solid object, it is quite easy. All you are going to do is once your scale reads 0.0, you are going to carefully place the object on the scale and simply read the measurement. In this case, we can see it is 13.8 grams. Now, let's look at how to measure the mass of a powder. Now, the only difference between measuring a solid and a powder is that a powder cannot just be easily placed on the scale and then removed. Therefore, we need to use something to keep the powder together and keep all of the sample contained. We use what is called a weighing paper. Since we don't have weighing papers in our lab, you can also use just a sheet of paper, or another handy tool is a coffee filter. So all you want to do is place whatever you're using as your weighing paper centered on the scale. Now, as you can see, very minimal, but this does have some mass. Now, we don't want to consider the mass of the weighing paper in the mass of our sample. So after the reading settles for the mass of whatever you're using as your weighing paper, you want to zero your scale again. This is because, again, we only want to know the measurement of the substance that we're trying to measure. We don't want to include the mass of the weighing paper. Then all you're going to do is take whatever substance it is. I'm going to use that sugar we used in our last example and carefully place it on the weighing paper, making sure that all of the sample is sitting on top of the scale. You will then, just like last time, once the reading settles, go ahead and read the measurement, which in this case we can see is 8.4 grams. The last substance I'm going to show you how to measure is a liquid. Similar to a powder, but actually worse, we know that a liquid, in order to stay together, needs to be inside of a container. For that reason, we also need to measure liquids in a very specific way. What you're going to need in order to measure the liquid is the liquid, and then another empty container in order to use to measure. So what you want to do is, just like with every other measurement, make sure that your scale is zeroed. You can see mine already is, but remember the trick, if it's not, to hit the tare or the 0 button. Then what you're going to do is take that empty container and place it on the scale. As we can see, this has a mass. In this case, it is 13.3 grams. Just like with my powder, I don't want to know the mass of the container that my liquid is in. I only want to know the mass of the liquid itself. Therefore, before I pour my liquid in, I need to make sure to zero my scale. Once your scale is back zeroed and has a reading of 0.0, you're ready to take your liquid and pour it into the container. And just as with all of our other readings, once that number evens out, you will simply go ahead and read your mass measurement, which in this case, 110.
Now that we know about mass and how to measure it, let's discuss volume. So volume is defined as the measure of the amount of space an object or a substance takes up. The unit for volume, there are two, one for solids and one for liquids. For solids, we use the centimeter cubed or the cubic centimeter. For liquids, we use the milliliter. Now, this may seem confusing, but I have one easy conversion factor that will make this very straightforward. 1 cubic centimeter is literally equal to 1 milliliter. So the conversion is a 1-to-1. So if you have a measurement in cubic centimeters and you want it in milliliters, all you need to do is change the unit because, again, it is a 1-to-1 conversion. Similar to mass, volume is also dependent upon the amount of matter present. For that reason, it also cannot be used to identify substances. Now, let's talk about how to measure the volume of different substances.
First, I'm going to show you how to measure the volume of a liquid. To measure the volume of a liquid, we use what is called a graduated cylinder, which looks like this. First, you want to make sure that you read your graduated cylinder and find out what each marcation represents. As you can see on mine, each one of those small lines represents 2 milliliters. So keep that in mind when doing your measurements. All you need to do is take your liquid and pour it into the graduated cylinder, which must be sitting on a flat surface. Once the entire sample is poured in, you want to look very carefully at eye level to where that liquid comes. In this case, we can see that I am at the 60 milliliter mark with 2 more markations above it. That tells me that I have poured 64 milliliters into the graduated cylinder. That tells me that my volume of water in this sample is 64 milliliters. First, let's look at how to find the volume of what we call a regularly shaped solid. Regularly shaped solid means that it is a geometrical, clear, known shape which could be easily measured and has a volume formula that is known, like a cube or a cylinder. For a regularly shaped solid, all you will need to do is measure the lengths needed in the volume formula. For the case of a cube, I simply need to know the length of the side and then use that measurement and the known volume formula for that shape to calculate the volume. Now let's look at how to measure the volume of an irregularly shaped solid. An irregularly shaped solid is not a normal geometrical shape, and it also does not have sides that could all be easily measured. It doesn't have a formula that can be used to calculate its volume, such as this set of keys. For shapes like this, we use what is called the displacement method. And in the displacement method, we need some water, the object that we're trying to measure, and our graduated cylinder. The first step of the displacement method is to fill your graduated cylinder with water. 2 things to keep in mind when deciding how much water to fill it. The first is that you want to make sure that it's going to be enough water for that object that you're trying to measure to be fully submerged. The second thing, which is not absolutely important, but I like to do it, is I try to make it so that it's a nice, even whole number, just so that the math is easier and things are easier to remember. So in this case, I'm gonna shoot for filling my cylinder up to 70 milliliters.
You want to be very careful and make sure that you are filling it to exactly the right volume.
Remember, when reading the volume of a graduated cylinder, you want to make sure that it is on a perfectly flat surface. And we can see there that my water is filled to the 70 milliliter mark. The next step is to simply take the object that you are trying to measure and drop it in, making sure that it does completely submerge inside of the water. Now I can come to my graduated cylinder and read the new volume after dropping the object into the water. I can see here that my reading is now at 74 milliliters. Now, in order to get the volume of the object, all I need to do is subtract the initial volume from the final volume. So in my case, that will be 74 minus 70, leaving me with 4 milliliters and the volume of the keys. So I now know that the volume of this set of keys is 4 milliliters, or if for a solid, we would say 4 cubic centimeters.